A rocket company is building one of the most powerful AI models on the planet. And it's not just building the model, it's buying the tool developers use to write code with it and deploying it inside the factories and launch facilities it already controls. In June 2025, xAI, Elon Musk's artificial intelligence venture, is rolling out Grok 4.5, a 1.5 trillion parameter model. Simultaneously, SpaceX is reportedly finalizing a $60 billion acquisition of Cursor, the AI-powered coding IDE that has become the default environment for a generation of software engineers. This isn't an AI product launch. This is vertical integration on a scale the software industry has never seen. Let's start with the model itself. Grok 4.5 is xAI's latest frontier model, reportedly weighing in at approximately 1.5 trillion parameters. For context, that places it in the same weight class as the largest models from OpenAI and Google DeepMind. But raw parameter count isn't what makes this release notable. What makes it notable is how it was trained. According to multiple reports, Grok 4.5 was built in explicit partnership with Cursor and fine-tuned on usage data from the IDE, meaning real-world coding patterns, edit sequences, debugging workflows, and the iterative loops developers actually perform. This isn't a general-purpose model that happens to code. It's a model architecturally shaped by production coding behavior. Cursor, developed by Anysphere, has exploded in popularity since its launch. By early 2025, it had reportedly surpassed 1 million paying users and was valued at $9 billion in its last private funding round. The reported $60 billion acquisition price, if confirmed, would represent one of the largest software acquisitions in history. For SpaceX, a company whose primary business is launching payloads to orbit, this is an extraordinary lateral move. It signals that Musk views the coding environment not as a peripheral tool, but as critical infrastructure, the interface layer where human intent meets machine execution. Grok 4.5 has reportedly been in private beta inside both SpaceX and Tesla for several months. Engineers at these companies have allegedly been using the model integrated directly into Cursor to write production software, flight control systems, manufacturing automation, vehicle firmware. If accurate, this means Grok 4.5 isn't being tested in sandboxed research environments. It's being validated against real-world engineering constraints where failure has physical consequences. This is a fundamentally different development philosophy than releasing a model to the public and iterating off feedback. It's closer to how defense contractors develop software, build internally, stress test against mission-critical applications, then release externally once battle-hardened.
Here's what makes this strategically unprecedented. One corporate entity would control 3 layers simultaneously. The model layer, Grok 4.5, generates the code. The interface layer, Cursor, is where developers interact with the model, and the deployment layer, SpaceX and Tesla, provide the real-world environments where that code runs. This is the Apple playbook applied to AI-assisted software development. Apple controls the hardware, the operating system, and the App Store. Musk is positioning to control the intelligence, the editor, and the deployment target. For developers building within this ecosystem, the upside is obvious: seamless integration, optimized performance, and a model that genuinely understands the coding workflow because it was trained on it. But the downside is equally obvious. When a single entity controls the model, the IDE, and the training data derived from your usage, the switching costs become enormous. Every keystroke in Cursor potentially feeds the next version of Grok. Your coding patterns, your architectural decisions, your proprietary logic, all become training signal for a model owned by someone else. This isn't hypothetical. Cursor's terms of service and data handling practices will become a central concern. Developers who've built muscle memory around Cursor's workflows, who've optimized their processes for Grok's particular strengths, face a familiar trap. The tool works so well because it's closed, and leaving means losing that performance. The competitive implications are significant. Microsoft already controls a similar stack through its ownership of GitHub, GitHub Copilot, and its partnership with OpenAI. Google has Gemini integrated into its cloud development tools, but neither has achieved the tight vertical integration that xAI is attempting. Anthropic, which has positioned Claude as the thinking developer's model, lacks its own IDE or deployment infrastructure entirely. The risk for the broader ecosystem is consolidation, a future where 2 or 3 megastacks compete for developer loyalty, and independent tooling becomes increasingly marginalized. Open-source alternatives like Continue and Void Editor exist, but they lack the resources to match frontier model performance embedded natively in the editing experience. The honest assessment is this: Grok 4.5 integrated into Cursor will likely be a remarkable product. A model trained on real coding workflows, deployed inside an IDE built for AI-native development, stress-tested against SpaceX-grade engineering requirements. That's a compelling pitch. But builders need to ask harder questions. Who owns the training data derived from your work? What happens to your workflow if pricing changes, if API access is restricted, if the model's priorities shift toward SpaceX's internal needs over external developers?
The history of platform dependence, from Facebook's API changes devastating app developers to Twitter's ecosystem pullback, suggests that building on someone else's vertically integrated stack carries existential risk. The deeper question isn't whether Grok 4.5 is good. It probably is. The question is whether the future of software development should be shaped by a single company's strategic interests. A company that also builds rockets, manufactures cars, and has the ear of governments. Vertical integration creates efficiency. It also creates dependency. And in an industry that was built on open standards, open protocols, and the radical idea that anyone with a text editor could change the world, the consolidation of the model, the editor, and the deployment environment into one corporate stack is worth watching very carefully, not with fear, but with eyes wide open.